what we'll be talking a lot about now for several weeks is the idea of functions. We'll be exploring all types of what we call functions. And so what we want to do here is talk about what we mean by a function. And actually, before we talk about what we mean by a function, part of its definition is another term, and that is a relation. And the deal with a relation is a relation is just a correspondence between any two quantities. A correspondence between two quantities. That's what a relation is. Correspondence between two quantities. That's all a relation is. Between two quantities. And we'll look at several examples. One of them, a correspondence between the time of day and the temperature. That's a relation, okay? Now, let's go ahead and talk about, there's several ways to denote relations and then function as well, but one way is just to do a table. You know, you got your time and then your temp on the other end. So 8 o'clock it was 70, 9 o'clock it was 72, and then 10 o'clock it jumped to 75. All right, that's a relation. We could have a relation between students and their classes. Students and their classes. All right, so let's say we got Jack and Jill here. And this is called a mapping. So Jack and Jill, and then over here we're going to have our possible classes, chemistry, math, English, and history. Well, Jack's taking chemistry, English, and history, and Jill's taking math, English, history. It's called a mapping. And so that's another way that you can set up a relationship in mathematics. Okay? So, yeah, I gave there, I guess you might say applications, but of course, we're a lot of times more concerned about the relationship amongst groups of numbers, right? A set of numbers. How do we relate one number to another one? Yeah, so we can establish relations just by ordered pairs, right? That would be 8, 70, 9, 72, 10, 75. So that's probably more in line with what we've covered so far. Yeah, just a relation between numbers. So we established that 8 goes with 70, 9 goes with 72, 10 goes with 75. So that's our relationship. That establishes the relationship for those numbers, in that particular case anyway. Which also brings up the fact that in the relation, we usually consider the first one the input, and then the second the output. And so same thing over here, input and output. We'll use that term here a little bit, input and output. Well, of course, the ultimate goal, I guess you might say, in establishing a relationship between numbers is to get an equation. And so that would be a fourth way, I guess, of writing a relationship. Y equals 2x. Would that establish a relationship between two quantities? Yeah, the y is going to be twice the x, 2 times the x. And so that would actually explain the relationship among all x's and y's in that particular case, right? And generally speaking, the way we operate is that the x's are the inputs, and then the y's are the outputs. General rule of thumb there. Okay? And so so if we have the equation, we can do the ordered pairs, we could do the table, we've done those already. We're just now calling these relations. Guess we could do a mapping too. You don't see that a whole lot. Could do it. Okay? All right, well, yeah, relation's pretty wide open. It can be just about anything. A function, on the other hand, well, that's a special type of relation. A function is a relation such that each input corresponds to exactly one output. That's what a function is. A relation such that each input corresponds to exactly one output. Okay, one and only one output. So that kind of specializes just a little bit. Some of the ones I had listed were functions, and some of the ones I had listed weren't functions. But let's just go through a couple here, new ones. So let's say I've got input and output table here. So I've got 7 input, output 6, 8 input, 4 output, and then 9 goes with 2. So the question here then is relation, but is that a function? Well, to be a function, each input corresponds to one output. Well, the good news here is I've got 7 going to 6, 8 going to 4, 9 going to 2. So each input corresponds to exactly one, only one output. So yes, that one is a function, right? 3, 4, let's do a mapping here. 3, 4, 5, 8, 9. 3 goes with 8, 3 goes with 9, 4 goes with 8, 5 goes with 9. So yeah, this one illustrates an example of when you have one input, but it's going to more than one output, isn't it? The 3 goes to the output 8 and to 9. So it's not a function, right? That one's not a function because you're 3. Now what if I had this? Input and output, 6 goes with 9. 8 goes with 4, 10 goes with 4, and 12 goes with 9. What about that? Is that one a function? Is that one okay?
Yes.
I've got duplicate outputs.
But only one of each.
Yeah, that really doesn't matter, does it? It's what happens with the inputs, isn't it? 6 goes with 9, so that input goes with one output. 8 goes with 4, and that's the only output it goes with. 10 goes with 4, 12 goes with 9. So yeah, this is a function. Even though we have duplicate outputs, each input just goes to one output. So yes, that one is considered a function. You can have duplicate outputs. Basically what it amounts to is you can't have, in a table situation, we couldn't have 6 going with 9, and then 6 going with 10, and 8 going with 4, and 8 going with 11, or something like that. You couldn't have the same input going to 2 different outputs. So that one's not a function.
So the input cannot be reproduced throughout the rest of the table, but the output can.
The output can be repeated, the input cannot be, if you're talking about a table, that's right. All right, what about this one? I guess that was 3. That was, oh, okay. All right, what about this one? So we got 3, 2. This one's the ordered pairs. 3, 2, 4, 5, 6, 10, 3, -2, and 4, -5. Is that a function?
No.
No, same deal, right? Same deal. If we consider the first number in the pair the input and the second one the output, you can't have a duplicate input, essentially what it means. So what about these two? Or these two? All right. Both of those will disqualify it, let's say. It's not a function. Yeah, same deal. You can't have, if you consider the input the first one, the output the second one, you can't have the first number in the order pair repeated in a list like that. Okay? All right? Now, so that's the mappings and tables and ordered pairs. How about this one? Y equals 2x. Is that one a function? Is that one a function? No. Say no? Well, again, yeah, you're just thinking here, if I consider the x the inputs, y is the outputs, what happens if I put in an x? Can I get a possibly different y other than one y? Like if I put in x is 1, if x is 1, what happens to the y? Can it be more than one value? No, it's locked in, isn't it? If x is 1, y has to be 2.
So it is a function.
If x is 3, y has to be 6. Is there any way to get 2 y's out of 1x?
No.
There's not going to be a way, is there? Now, I'll show you an equation where you can, but not here. There's no way to get more than one y off of just plugging in one x. If you plug in an x, you're going to get just a singular y, right? So that, I mean, that we're not proving or anything. We'll look at other ways that we can determine whether an equation is a function or not. But right now, you're just kind of looking at, well, can I plug in an x and get more than one y? In this case, no. So this one is a function. Let's say it this way: nx will just give you one y. And if that's the way we're selecting input and output, which that's generally the way we do, this is a function. This is, well, what we say is y is a function of x, is how we would say that. Y is a function of x. And that's generally speaking the way we go with it. Okay? Now, if I had x equals the absolute value of y,
Okay, so no, it's
do we
not a
see
function.
a problem with that? You see a problem with that?
Yes. Because you could put a negative and a positive number in y and still get the
Let's go with
same
4.
x.
All right. So let's say we've got x is 4. What could y potentially be?
Negative 4.
So we got 4 equals, so 4 is the absolute value of y. So y could be 4, but is there anything else?
Y could be negative 4.
Or y could be negative 4, couldn't it? That's right. If I have x is 4, then I've got a choice, I guess you might say, or a possibility that the y could be 4 or y could be negative 4. Because you do the absolute value of the y, you get 4 in either case. You see that? So you kind of do several of these, you kind of get a feel for it, but yeah. So that's not. So that's the thing on these. What you're looking for is just, what if I plug in an x? Is there more than one y I can get out of that then? Okay. All right. One other term, I don't know that it comes up on this homework, but another term that we'll see is domain. Two terms: domain and range. Possibly heard of those before, but for functions, we consider, well, I guess relations too, but the domain of a function and other things, but that's just the set of all inputs. And then the range is the set of all the outputs. And like I said, we'll do more with this one later on, more with those terms later on, but just to give you a preview, I guess. All right, so let's say we've got y equals the square root of x. So the domain being what I can put in for x, and I'm talking about real value. I have to have real values. We're not going to go into complex values for these. If both numbers have to be real numbers, doesn't that limit what my x can be here? What can x be here? Well, since it's under the square root, I can't do negative squares because square roots of negatives. Because if I do the square root of a negative, that's going to give me an imaginary I number, right? And those aren't real numbers. They're outside of the real number set. So here, the set of inputs, x can only be 0 or greater. X is greater than 0, so that would be my domain here. You see what I'm saying? And we'll talk more about it later on. But the x would have to be greater than 0. And the range, what's going to happen on the range also?
Opposite.
So what are the outputs going to be? If I plug in 0, I get 0 for y. Am I going to get anything less than 0 for y? Because I'd have to go the square root of 1, which would be 1, the square root of 4, which would be 2. Anything I plug in for x here that's allowed, it's going to give me a positive number, and of course 0. So isn't the range also going to be y has to be greater than 0 as well?
Greater than or equal to, right?
Greater than or equal to, yes. Thank you. I forgot the equal to, didn't I? I said we could use 0, and I forgot to put it, but yes, thank you. All right. So anyway, that's, like I said, just kind of a preview of domains and ranges. We'll get more into that later on. Okay, well, the other part to consider here today, including on this set, is what we call function notation. Function notation. What function notation allows us to do is be able to recognize whether or not something's a function just right off the bat, without even having to say, well, if I plug in this x, do I get more than one y? You don't even have to do that. If you've got it in function notation, you know automatically it's a function. Okay? Well, let me just first of all tell you. All right, so we said y equals 2x. That was a function. Here's what function notation does. All function notation does is it replaces the y with another expression, and it's the expression is typically f parentheses x. I mean, we can use other letters there, but yeah, this is the so-called, this equation in function notation, f of x equals 2x. It's just a replacement of the y. In other words, f of x equals y. Those two are one and the same. Y is equal to f of x. It's just a renaming of y. And like I said, if we see this notation, we automatically know it's a function. Now, the parts of the function here, the f is, that's generally speaking considered the name of the function, or the designation of the function. F, I guess you could have that name. But that's considered the name of the function. Of course, the x here, the parentheses x, that, the nice thing about that is, yeah, that is considered your input value. The way we read this, and of course, the 2x is the defining expression for that function. So this right here defines the function. So in this particular case, our function f f of x is 2x. Okay? And of course that will vary depending on the type of function we have. All right. Yeah, and the way this is read, generally speaking, is f of x. F of x.
Can I ask you what the output would be?
What?
What would the output be on that?
So the output, the output's the y, right?
But it's
And
replaced.
so
Got it.
in this particular case, the y is equal to 2x. So this is the output, yeah. The defining expression is the output. That's a good question. So that's going to be your output, yes. All right. Well, what they have us do, starting us off here a little bit, is say we've got f of x equals 3x plus 1. So we've got a different function, different f here, but f of x equals 3x plus 1. And so let's evaluate f parentheses 7 is what it looks like, f of 7. Yeah, and so this is just a nice way of writing kind of a, if you didn't have this notation, it'd be a little bit wordier. What's this saying? Well, I want to do function f, and I want to do input 7. This is my input. And so to do f of 7, that's exactly what you're going to do. You're going to input 7. In other words, x is going to be 7. That's the x value. Yeah, I'm just going to plug in f. So this is a nice way of asking what is the y value when x is 7. You just have to say f of 7, though, when you've got it in function notation, you see. But, yeah, f of 7, you just plug in the x to be 7. So it'll be 3 times 7 plus 1, 22. Okay. All right. Now, they don't always have to be f functions. We'll have some g's, maybe some h's. So let's do a g of x function. G of x is x squared plus 4x plus 3. All right, so number 1. What's g of 3? Well, that's saying input 3, so we're going to plug in the x to be 3. Now in this case, we've got a couple of x's, and so each place there, the x is 3, right? So we have 3 squared plus 4 times 3 plus 3. So g of 3 is going to be 9 plus 12 plus 3. 24?
Mm-hmm.
Yes.
What about g of negative 6? G of negative 6. Well, just like as always, be careful with your negative signs. I'm plugging in negative 6 here and here. And so what have I got? Negative 6 squared.
36.
Positive, negative.
Positive.
Positive 36, yes. Negative 6 times negative 6, positive 36. Yeah, just got to watch the sign. Now here I've got 4 times negative 6, it's negative 24, isn't it? And then plus 3, 15?
Yes.
15. Problems or concerns? Good? All right, well.
And you want us to leave the other side of it in the same form, so just leave the other side as g negative 6 or whatever?
G of negative 6, yes.
Okay.
Yes. All right, let's do a third one here. And let's do g of x plus 4. Yeah, it turns out those input values, you don't necessarily just have to input a number. You can input an expression. So in this case, our input is x plus 4. And so wherever we have the x in that case, we're going to put x plus 4. so if we write it all out, isn't that what we've got? So for x, I put in x plus 4. It's going to make x plus 4 squared. And then 4 times the x plus 4. Now, what they'll want us to do with that is simplify it. And again, be careful because I don't think we've covered one quite like this before, but x plus 4 squared, that is not x squared plus 16, is it?
No,
There's a little more to it, isn't it?
X plus 16.
Yeah, I mean, if you know a rule, that's fine. But x plus 4 squared means you've got x plus 2 twice. And so you've got a little more there than x squared plus 16, because really what does that amount to? You got to FOIL that out, don't you? Since I've got x plus 4 times x plus 4, I got to FOIL that out. So you've got x squared. Like I said, if you know the shortcut, but x times 4 is 4x, 4 times x is 4x, 4 times 4 is 16. So yeah, you got a couple more things than just x squared plus 16 there. And then here, it is just distribute. So 4x plus 16, you distribute there. And then we can combine like terms. So what have we got? X squared, 12x, and 35 plus 35. Good? Okay, now, let me throw this one at you. What would g of 4a minus g of 1, what would that one be? Yeah, you can mix and match, put two function values together like that. Yeah, if we've got, so this is two function values subtracted, so what are we going to do?
Yeah.
Just do the function value for 1 and then subtract whatever the function value. So yeah, it's basically you want to compute that function value and then subtract whatever that function value turns out to be in that output. So what have we got here? Well, 4a, so we'd have 4a squared, 16a squared. And then 4a, you can write it out if you want to. That would be plus 16a and then plus 3. So all of that is my g of 4a. And then minus g of 1. Well, g of 1, I'll have 1 plus 4 plus 3. Just be careful with your signs there. G of 1, just plug in the 1, you'll have 1 squared plus 4 and then plus 3. So we've got 16a squared plus 16a, and what would that be? 8. 3 minus 8? Negative 5? So where do you get that? This right here is 8. So you have 3 minus 8, so you have negative 5 there. Okay, so you can do all sorts of things with function values. Okay.
And that's as far as you have to go on the...
Yeah, that's as far as, yeah, these, on these last two, yeah, the function, the answer will just be an expression. And so yes, that's as far as you have to go with those. You don't, there's no solving, these come out to be numbers, but yeah, this isn't really an equation or anything, so that's it. Stop right there. Yeah, and you don't even have to use x necessarily. Let's say we've got h of t, so our function is h, and then our input is t. That's okay. You can do that. So h of t equals the square root of t plus 8. It's a function. We know it is a function, and it's in this case we would say h is a function of t. And so that. Then the other thing they'll also have you do is make a table of values. And I think they, in the book here, they line it up horizontally here, so I'll do that too. So yeah, we're just going to do a table of values with t and then h of t values. But it's just like we've done before. They'll give us here, let's say, maybe let's go with 1, 2, 3, and 4 for my t values. But it's the same drill as before. They give us the t values, we just have to figure out the h of t, so it's the same thing. These are input values, so we plug in 1, what have we got? Square root of 9, 3. Plug in 2, got the square root of 10, and they'll typically just simplify the radical as much as possible. That one doesn't really simplify. You don't have to round it, in other words, to decimal or anything. Just simplify it if you can. 3 would be the square root of 11. Now, with 4, we'd have the square root of 12, so that one does simplify. They probably write it in simplified form. What would be the simplified form of square root of 12?
Square root of 3.
Well, 12 is 4 times 3, so it'd be, in this case, just 2 square root of 3. 2 square root. 2 square root.